So let's get started with learning the concepts. But first, let's figure out how we are going to structure this video. First, I opened an empty project in WebStorm, where I currently have nothing. Next, I will create separate JavaScript files for each topic. For example, we will start with data types. So I will create a file named 01_types.js. And here I will write some code. Let's say I write console.log hi here, and in order to check what results we will have in some variables or functions, I will run all of this on the node.js platform. It will look like this. I right-click and run 0.1 type.js, and I get the message hi here. If you are not aware, what is happening here? In fact, I have node.js installed on my computer, and you can easily install it as well by visiting the official website. And to run a file, if you don't have WebStorm, you can open any terminal. On Windows, it could be CMD, and on Mac, it's just the terminal, for example. Next, you go to the folder where your project is located. In my case, it is WebStorm project JS concepts. And here, to run the file, you type node followed by the file name. In my case, 01types.js, then press enter, and here I get hi. To have auto-completion like this, you press tab and everything should work. Alternatively, there is another way you can run these files to test them on your computer. You can simply create, for example, an index.html file, link the script to it, and then run everything in the browser, including console logs. But in this video, I will be using this particular approach as it is the fastest and provides the necessary results. And now that we have dealt with the technical aspects, let's move on to the types. For this, I have just created the first file. And perhaps this is the foundation from which one should generally start learning JavaScript and understanding what is happening here. So, there are 7 data types in JavaScript, and you should remember this. So, the first type is null. Well, the order of them is not important accordingly. The second type is defined. Then there's Boolean. For example, number, string. Text is object, and the 7th data type, such as 1, 2, 3, 4, 5, 6. Yes, this is a symbol that appeared in the ES6 syntax. In JavaScript, there is a special operator called typeof, which essentially allows you to find out what type of variable or a value is. Now, let's take a look at each of the data types. That is, I can use typeof in this way and pass, for example, the value of 0. As a result, I can get number, which means it is a primitive data type. By the way, I forgot to mention that all these data types are primitive, except for the object. The object is the only one that is non-primitive. Let's return to typeof. There is such a notation, but more often you can see this notation where everything is written without parentheses. In other words, we use it as a regular operator. If I check the script again, it returns a number. So 0 is a number, accordingly. Let's look further. For example, typeof true. This is a boolean. Let me go ahead and write down all the other data types. Typeof, for example, string, and accordingly, strings are written in quotes. By the way, there are 3 types of quotation marks: double quotes, single quotes, and backticks, which are called literals. These quotes are not different. Literals have a special property, meaning that they can be used to pass various dynamic data. Next, let's say I will just write typeof undefined here. This is also a data type. Next, we have objects. Here I can write typeof. An object is created using curly braces. Or, for example, I can pass some existing classes here, such as date or math. And for now, let's take a look at the result. So here we have number, boolean, string, undefined, and object, which is all quite logical. Now let's also look at symbols. Symbols are defined through a class called symbol, and we need to pass a specific symbol to the constructor. For example, JS. If we look at this data type, we can see the symbol. The only data type I haven't mentioned yet is null, because if I type typeof null in the console and run the script, we will actually see object here in fact. And this is the first inaccuracy of the type-off operator, which returns object for no. In fact, no is of the data type no, and it's important to remember this. If we are already talking about the inaccuracies present in the type of operator, we can check them in the following way. Write type off. Let's definitely release function, and in the end, we will get function here. Although in reality there is no data type such as a function. Functions are essentially objects. However, in order to make it easier to develop applications and understand where functions and objects are, the type-off operator returns function for a function. Accordingly, we can work with this. And there's one more interesting point about the type-off operator. If we write type-off none, none is a special value in JavaScript that literally translates to not a number, meaning it is not a number. A fun fact is that if we run this script, we will get a number here. That is, it is a number, and in fact, it really is a number. This is the kind of inaccuracy that exists in JavaScript. For example, we can get none if we divide by 0. Yes, we can say that here we can write 1 divided by 0. Here we will still get a number. But if we look at what 1 divided by 0 is, we should get none. No. Here we actually get infinity. A good example might be this image. Let's say undefined multiplied by 1. Then we should get none. Right now we get none. But we'll get to that a bit later and see how it works. For now, we can delete all of this. I'll return none here. Either way, you might ask, what is the difference between undefined and null? And in fact, such a question is often asked in interviews. Why do we need 2 such data types? Well, actually, the data type undefined is used when a variable is not declared, or it was declared using a keyword, such as var, but does not have any value. The advantage of functions that do not return anything is that they return undefined by default. Null, on the other hand, indicates that we are specifically lacking a value. That is, the variable is declared, but it has no value. For example, there may have been some object, string, or number before, and then we reset it and assign 0 to it. So this is roughly what the difference is. Now let's talk a little bit about type conversion. And for this, I will create an example. So I will write, for instance, let language equal the string JavaScript. And then I can ask, what if we have a variable called language? Then I will output the following to the console. Let's say, for example, best. The language is, and here I will pass this variable, and for now, I will just comment out all these types so they don't interfere with us. So, this is a completely basic example for JavaScript. What is happening here is that we essentially take a variable that contains an empty string and check it in the if statement. However, the if operator essentially works only with Boolean values. Let's take a look at the result we got. If I run it, we actually get a string. This means that the if statement executed successfully and everything is working correctly. And so, log outputs the desired value. In other words, when the JavaScript interpreter encounters such code, it essentially sees the string JavaScript instead of the variable language. It recognizes that this is a string. And what does it do? It takes a string data type and converts it to a Boolean data type, meaning either true or false. So, accordingly, such a line is coerced to the value true, which results in if true, and then we get the desired value in console log. Type coercion is quite an extensive topic in JavaScript, but essentially, what is important to understand is that there are certain values that are coerced of false, known as false values. In English, these include, for example, an empty string, 0, no, undefined, and of course, false itself. That is, these values, when they are coerced to a Boolean value, yield false. This can be easily verified. Let's say that if we refer to the global Boolean class, we can pass some values to its constructor. For example, an empty string. And let's see what will be output. That is, we get false. Now, let's look at some other string, for example, the string hello. Here we will definitely get true because this is not an empty string. For example, if we simply pass a space here and run it, it will also be true because it is no longer an empty string, and the space character is a character that is contained in a string. Next, let's say if we specify 0 in string format, we will still get true because it is not just 0. It is a string that contains a character. But on the other hand, if I just pass a number here, we should get false. See, false. And accordingly, if we pass other values here as well, we will get false for each of them. Well, for example, with no, yes, here we get false. However, everything would be fine. But this is JavaScript. So if we pass an empty array here, for example, we will get true. And an empty array is indeed coerced to a positive value, just like an empty object and just like a function. All these values yield true when coerced to Boolean, and it's important to remember this. Okay, I will definitely comment on this. Let's move on indeed. Next, within the topic of types, we will discuss in more detail how strings and numbers work. Because this is quite a broad topic, it's important to understand what is happening in general, as this is often asked about in interviews. Also, in this format, I will be outputting certain values at the end using console log. Well, let's say the first thing we can look at is, for example, 1 plus the string 2. What do you think the output will be? So, basically what's happening here, right? We have a number and we have a string, and we're trying to add them together. It is important to remember that there is an addition operator for numbers, which performs the addition operation, and there is also an addition operator for strings, which serves the role of concatenation, meaning the addition of strings. So right now, if we look at it, we see that we get 12 as the output 12, because JavaScript, when it interprets this line, sees that we have a number in a string here. In this case, it takes the string and uses this symbol as a concatenation operator. And so it converts the number 1 to a string format, and we get the output as the string 12. But it is important to understand that this is a string, not a number. We can see the same thing if we, for example, just take an empty string, say, add the number 1 to it, and then add 0. The output will be the string 10. Let me run this. We get the string 10 because, again, JavaScript sees that there is a string here. It converts the number 1 to a string, and then it results in the string 1 plus 0 concatenation, which gives us the string 10. But it is important to understand that this is not a number. However, another example is if we take an empty string, for instance, and try to subtract 1 and add 0. Here, WebStorm is already highlighting some possibilities for how to improve this. But if I run this code, I get -1 because we have a string and a number, but the minus operator is not defined for strings, so it treats everything as a number. Thus, -1 plus 0 will be -1, but this is already a number. In the next example, if we take the string 3 and want to multiply it by the string 8, what do you think the output will be? Again, we should follow the same logic that the multiplication operator is not defined for strings. So JavaScript will convert these strings to numbers. Therefore, the output will be the number 24. However, the order is very important because if we, for example, write such an expression, say 4 plus 10 plus pixels, then the output will be 14 pixels. Because JavaScript looks at this number and that number. For numbers, the addition operator is defined. Okay, this addition will be 14, then the number 14 plus the string pixel. And it concatenates this as strings. So in the end, we get a value of 14 pixels. If we, for example, change the order to say pixels plus 5 plus 10, then we will get pixels 510 as the output, because it was initially coerced to a string, and then a string plus a number. We already know that this will be a string, so here we also have a string. In this case, if we have a value of 42 and we, for example, subtract 40 from it, then we have a string, this is a number. But considering that there is no subtraction operator for strings, we will get a 2 here, as JavaScript will coerce it all to number. But on the other hand, if we have, for example, a string like 42 pixels and we want to subtract 2, we will end up with nan, because when converting the string to a number, we get nan, and then 2 will also be man. So it's worth remembering this as well. In this case, we don't have any additional strings, so this line was successfully converted to a number. And there are a couple of other interesting types regarding conversion. For instance, if we add 2 to 0, we will get 2 because 0 when converted to a number equals 0. And in the example we discussed, if we try to add 42 or any number to undefined, we will get man because undefined cannot be converted to number. The next thing we will look at in the topic of types is, let me write a comment that we will also consider a very interesting operator, double equals versus triple equals. In fact, if you are asked in an interview what the difference is between these two operators, you will often hear the answer that double equals compares only by value, while triple equals compares both by type and by value. Although this is not entirely correct, because double equals compares values, but with type coercion. Yes, and the JavaScript interpreter tries to coerce types, as we discussed here. The triple equals simply compares by value without type coercion. Yes, and thus we get a slightly different but more precise formulation. Here, as an example, let's also comment everything out. For example, we can provide similar constructions, say 2 equals 2, but already in a string. And here we get true because the JavaScript interpreter tries to coerce everything to one type. But in this case, if we use triple equals here, we get false because JavaScript does not coerce them to the same type, but compares them by their values. Values are indeed different. The same goes if we compare undefined and null using double equals. We will get true here. However, if we use triple equals, then these are different data types, and therefore we get false here. And in fact, that is why it is recommended to always use triple equals to avoid any errors, as many problems are related to type coercion. If you use triple equals, the chance of having any issues in your code decreases. I also want to show a few more interesting examples regarding double equals and triple equals. For instance, if we compare the string 0 with the value false, what do you think we will get? There's no need to guess. Let's run the code. We will get true here because, in fact, the interpreter, when we use double equals, tries to coerce everything to a number. False gives us 0, the string 0 gives us 0, and that's why we get true here. A similar example is that if we compare 0 and 0, we will also get true here. Well, accordingly, if we simply compare 0 and 0, we can even use triple equals here, and we will also get true, though such interesting constructions can also be taken into account. Okay, I commented. Here is a small new chapter, and here I will show you perhaps just a list of some comparisons that can be super ambiguous, which you might be asked about in an interview, so it's definitely worth remembering them, or at least just playing around with them, because all of this is not very clear, maybe for beginners. That is, let's say we are comparing false and an empty string. But I would like to point out that here we are using double equals. We get true here. If we compare false and an empty array, you will be surprised, but we will also get true here if we look. In the console, if, for example, we compare false and an empty object in this case, we will get false. Next, let's consider the following point. If we compare an empty string with 0 and also write an empty array and an empty object here, we get some interesting values as a result. In this case, true. And in this case, true, but when comparing with an object, we get false. This is exactly the same situation as with the value false. However, things would be fine if it weren't for the next example where we compare 0 with an empty array 0 with an object and 0 with 0. So in this particular case, we should most certainly definitely get true. When we compare with an object, we still get false. But when we compare with 0 using double equals, we still get false. These are some interesting checks that you might be asked about. In principle, there are many similar examples. These are just some basic ones that you should understand. It's important to realize that working with empty arrays and objects is not so straightforward. We have talked about data types and type coercion, but let's move on. Let's talk about some values and how they are defined in JavaScript. I will name the file 02values.js. In JavaScript, the primitive data types we discussed earlier are essentially passed as values. But if these are data types that are mutable, such as objects, arrays, and functions, they take and pass a reference when, for example, creating new variables, and because of this, certain mutations can occur. Let's look at this with a simple example. That is, say I create a variable that equals 42, and, for example, I create a variable b that equals a. Next, I will take and increment b, meaning I will change the state. And let's look at the state of variable a and examine variable b. So, if I run this file, we essentially get the expected result. That is, we have variable a, which remains 42, and variable b is equal to 43, because here we obtained the value that was in variable a and simply copied its value because a is a primitive. And that's it. We work with b in isolation from that point on. Now, the next example shows how computed specific data types work, such as arrays. That is, let's say here I can create a variable, for example, c, and let's also have a equal to 1, 2, 3, for instance. Next, I will create a variable b that will equal the array a. Now I will take into account that we have an array in variable b, and using the push method, I will add, for example, the number 4 to it. And now, if we look at variable a and look at variable b, when we run the script, we will see that both of these arrays store the same value. That is, when we initialized variable b through variable a, we did not copy the actual value in the array, but rather we copied it as a reference to the array. Essentially, we are storing the same value here, meaning that variable b currently holds a reference to variable a. And considering that when we change variable b, variable a also changes. So how can we avoid this? Well, let's say we can return a clone of the array so that it doesn't mutate. For example, here we can call the concat method. In this case, if I run the script, we see that variable b operates in isolation, so it does not mutate. Since the concat method has no parameters, it takes and returns a copy of the array. So I will remove concat to demonstrate another interesting thing, which is that in the end we get two arrays, each consisting of the 4 digits 1, 2, 3. And let's say now I can create a variable c that also consists of 4 digits. And now we can ask the console logs, what if variable a is equal to variable b through triple equals? Yes, but here we are passing it as a reference, so here we will get true. But we can also ask if, for example, variable a is equal to variable c, which contains exactly the same value as variable a. In that case, we will get false as the output, because in reality they are already different objects, and when translated they have different values there. But a and b in this case are the same, and therefore we get the value true, which pertains specifically to values and the passing of values as references. The same applies to objects, but arrays are essentially a special case of objects. So we move on, and I will call the next topic scope.js. What is, in general, scope? Essentially, this is something that tells us about the availability of certain variables in functions. In our code, essentially, there are two concepts, global scope and local scope. So what can be said about global scope? It is when variables are declared, for example, outside of a function, but are accessible within all functions that are within that scope. Now let's look at an example. For example, in the browser, the document or window object pertains to the global scope, meaning they are accessible in all functions immediately. There is a local scope when a variable is accessible only within the confines of a single function, or in nested functions. Now we will look at this again. So, what is important to remember about scope is that it indicates the availability of certain variables. Yes, it is indeed absolutely the scope. Let's create the following example. Let's say we will simply have a global function. I will name it func_a, and here I will create a variable a which will be equal to 1. This function is a very ordinary function, and inside the function we can also create other functions. For example, function func_b, and I am already creating it inside function a. Here I will create a variable b which will be equal to 2. And inside function b, I will also create a function that will be called func_c. Here I will create a variable c, which will be equal to exactly 3. Then inside the function c, I will log a, b, and c to the console. In function b, after I define function c, I will first call function c. Let me write here what this function is. In func_c, I simply call function c and will also log func_b to the console. Here, I will output not 3 values, but only a and b because, in this case, we no longer have variable c as it is declared only within the scope of function c. You will confirm this shortly. Similarly, for function a, I also call function b and log func_a to the console, where I will display variable a. Same situation applies here. Variable c is not present in function a. You see, that is, if I collapse it, there are no variables b in it, and therefore the variable b is not accessible. But at the same time, it will be accessible to child elements. And then I will simply call function a. If we look at, so we essentially get the expected result everywhere. That is, function a contains only variable a, which equals 1. Function b, in turn, when it is called, outputs a and b, but within function b, only variable b is in fact defined. However, function b is within the scope of function a, meaning that variable a is also accessible within it, and therefore we can refer to it. Well, the function c, considering that it only has the variable c, can also see a and b due to the scope. Therefore, it can output them. In other words, it's actually very simple. If a variable is declared above, it is accessible to the function. If it is declared at this level, for example, then it is already unavailable for function a. Basically, there is nothing complicated here. This is the entire scope. The next topic we will discuss is called hoisting. It's create a file. Hoisting.js is a very important topic for JavaScript that essentially shows how the interpreter works. For example, if I create a function called sum that takes 2 numbers as parameters and returns their sum, there is nothing complicated about it. If we try to call this function with the values 1 and 41, you will be surprised, but we will indeed get 42. Everything works as it should indeed. However, JavaScript allows us to do it a little differently. That is, we can call the sum function before we defined it this way. If I run the script now, I will still get 42. What is conditional hosting? This is when JavaScript, while interpreting a file, takes and effectively moves the definition of certain things, such as functions, to the beginning of the file. This means we can refer to them even before we have defined them. For example, like here. And let's go over some examples of what you should know about hosting. That is, for example, I have a variable var I, let's say, which equals 42 just naturally. And now I will try to output the variable I. Let's take a look. We get 42, which is basically logical. But what if I try to log it to the console before I have even defined it? So here I got undefined. That is, we don't get any error. We are simply saying that the variable I is currently undefined. It has not been defined yet. But at the same time, the interpreter already knows that this variable will be defined later in the script, and therefore it returns some value here. In exactly the same way, we can see that if we predefine, say, var I and try to execute the same code, we will get the same result. Because here, when we define the variable I, it is by default set to undefined, and we input undefined assign 42, output 42, and everything works. There is a difference when using, for example, the keyword var and, say, the keyword const. That is, const and let variables are not subject to hoisting. Now let's take a look. That is, let's say I try to output the variable number. Then I try to create a variable number that equals 42, and I try to output it again in the console. That is exactly the same example we discussed above. But if I look now, we just get an error where we have a reference error stating that we cannot access the variable sum before it has been initialized, which is basically logical, although I will reiterate that if we change this to var, then as you can see, we get all the previous values. The exact same thing happens with the keyword let. That is, if we create variables in this way, we get a reference error. We cannot access the variable number until it has initialized. So this is exactly where the difference lies. I will comment on this. And I also want to touch on the topic of hosting regarding the so-called function. Expression and function declaration. That is, different ways to declare a function in various ways. For example, as I mentioned before, we can create a function as an example, let's say square, that will take a parameter called number, and it will simply return number raised to the power of 2. And we can call this function square before. We have defined it. So we can take a look. Square of, say, 25. You should get 625. Let's check. Yes, we get 625. And this way of creating a function is called a function declaration. However, we can create a function through function expression. And let me copy this and comment it out. We can write it in such a way that we create a variable square to which we assign the value of a function, meaning we are storing the function's value in the variable. Essentially, we can also call it, but if we try to use the keyword var, we will get an error in this case because square is not a function. In other words, there is a difference. If we use a function expression, the functions defined in this way can only be used after they have been defined. If we move the call down, everything will work. But if we use function declaration, we can essentially call the function anywhere, regardless of where it is defined. So this is where the difference lies in the interview. I often ask what the difference is between expression and declaration. Now let's talk in more detail about things like let and const. It's also very important to understand their differences, although they are actually quite simple. And first, let's talk about the construct known as let. With the introduction of the new IIFE syntax, instead of the keyword var, which stands for variable, we can create different variables using the two keywords let and const. Let essentially allows us to create variables that we can later change, meaning we can reassign them. And let's consider an example. Suppose I create a variable a, which will be equal to the value of variable a. Then I will have a variable b, where I will write variable b next. I will proceed as follows. I am using curly braces here, and this is called block scope. That is, now in ES6 syntax, all such curly braces create their own specific scope. And what am I going to do here? Essentially, I can refer to the scope here, where we have access to variables a and b, and I can assign the variable a to the value of the new variable a. Say, in this way, basically, and considering that the variables a are available to me in the scope, everything should work nicely. However, if I create a variable b in the new scope that equals, for instance, the value of the local variable b, then let us immediately look at these values. That is, I will be entering into the console. let me just write scope better. Here I will simply write scope b. I will output variable b. I run it now. So we get, in principle, the expected values, meaning that variable a has the value new variable a because we changed it within the scope, and variable b takes its value from this because a variable created with the keyword let is only accessible within the block scope, meaning it is only available within these curly braces. And accordingly, this variable b does not affect this variable b in any way. This can be easily demonstrated if we write, for example, just a here we will input the variable a, and here we will write variable b, variable b. If I run it now, then what is in Sculpey we have already discussed. And now, regarding the global Sculpey, variable a has been changed because we specifically referred to this variable here as we used the keyword let. In this case, the variable b remains the same as the one we left by default, because when we tried to create the variable b inside this block scope, it is only accessible within those curly braces, and it does not conflict with that variable b. Now, if we talk specifically about the topic of hosting, if we try to log the scope, let's say c, and here the variable c, let's say I write something here, we will get an error because we are trying to access the variable c before it has been declared. We have already discussed this. Everything you need to understand about the variable let in this case is that it can change, as you can see, and it is only accessible within the block scope, that is, within the curly braces. Now, regarding constants. For this, there is the keyword const, but in reality, these are not quite constants because we are working within JavaScript, yes, and everything ultimately comes down to variables there, var. Constants, indeed, if we, for example, declare a variable, say port, for instance, 8080, and then try to reassign it, say port equals 2000, it is already clear that WebStorm highlights it in red if I run it. So we get an error assignment to constant variable, meaning we cannot change a constant, which is interesting, but this applies to primitive types. However, there are things like arrays and, for example, objects. For instance, if I create a variable called array where I have an array consisting of several strings, let's say JavaScript, it is obvious that right now the array simply contains a set of strings. But I can access the array and use the push method to modify it, for example, to add a new element. If we look at the array, we will see that it now consists of 4 elements. That is, we also have access to methods such as shift, unshift, pop, and so on. In other words, we can easily modify the array using them. Moreover, we can not only modify the array using these methods, but we can also directly access the index, for example, the 0 index, and say that instead of the word JavaScript, we will have the string JS there. Now, if we take a look, we see the modified values of the elements. That is, in this way we can also do it, and at the same time the state of the array changes. But the point is that we cannot, for example, write our equals an empty string, but is already an error. And that's how constants work. When considering the context of objects, everything is quite simple here as well. Suppose if I create an object as an empty object using the keyword const, I can still modify the fields of that object. That is, for example, obj_name will equal owner, and let's say objage will equal 26. If we look at the object, we will get its values already filled in. In this way, at the same time, I can change these values. So let's say obj.age will equal, 21. Looking at obj, we will see 21 here obviously, meaning that I can change the internal values of the object freely. I can delete them using the delete operator, for example, delete obj.name, and we will only get the age field. So on. This is the same story, but we cannot set obj to an empty string or a number because we can only change the internal state of this object. Okay, everything is good, let's move on. The next topic, which is also extremely important for JavaScript, is closures. In English, they are called closures.js. What is a closure? In fact, a closure is the moment when a function has access to variables from an outer scope. And that's basically it. One could say that it's a function within a function, but in reality, it's when a function closes over certain values from an outer scope. Let's consider a simple example to understand how the principles of closures work. We will look at them now a bit. Let's say I create a function here called sayHelloTo, and I will pass a parameter name to this function. In other words, I will be greeting a certain person. Well, for example, here I will create a variable message where it will say hello, and here I will specify the variable name. But what exactly will I return from this function? Precisely. From this function, I will not return the variable message. I will return a new function. Thus, for example, I will output the message in the console logs. As I mentioned earlier, a closure is when a function has access to the outer scope, or more precisely, to its variables. So this anonymous function has access to the outer scope where the variable message exists. See how this works. That is, I can create, for example, a variable hello2. Let's write here Elena, and this variable will contain the result of the function sayHelloTo. So I write Elena, which means I am passing the parameter name, but the function sayHelloTo returns a function. This function is equal to that function, and it does not have a variable like message within it, for example. However, message is accessible to this function from the outer scope, meaning it has kind of closed it within itself. Now, if we look at what hello2Elena is and run the script, we get a function here. This is a function, and therefore we can call it hello2Elena. I call it without any parameters, but in the end, I get hello Elena here. I also got undefined here for one simple reason. This function does not return anything, and as I mentioned in the first part about types, a function that returns nothing by default returns undefined. So if I remove console.log, there is still console.log inside this function, so we will still get the value hello Elena. The same story applies if we create some other variables, for example, hello to Igor. This means we are now closing the variable message with the value y in this function. And now, if we basically call this function without parameters, we get y here. This is how closures work. I'm commenting on everything. Let's move on. What practical applications do closures have? Well, for example, I can create a function. For instance, let's say a new framework manager. Let's even name this specific function called the create framework manager function will not take any parameters. Let's say I have an array called frameworks, which will consist of Angular and React, such as, for instance, what this function will return is an object, and I can also create certain functions within that object. Well, for example, I will implement a method get, which will be a function, and which will have access to the outer scope. In this case, it is also an inner function that has access to variables from the outer scope. And let's say I would rather call it log, or better yet, I might even call it print. Here I will simply log the value of, let's say, the array frameworks in console. Log. And for example, I will implement the method add, which will also be a function. This means it will take a parameter framework. Everything I will do, I will again not store anything in this function, but I will access the variable frameworks and use the push method to add a new framework to it. Now, how can I work with this? Let's say I can create a variable manager from the function createFrameworkManager without any parameters and more easily. Now, if we look at the variable manager in the console, we will see that it is a regular object that has two methods, print and add. What is very interesting in this example is that if we try to look at the variable frameworks, we will indeed get an error, because frameworks is not defined. That is, we do not have the variable frameworks anywhere, yet we can still interact with it through the manager object. So, for example, we can refer to manager and call the method print. If I look at it, we get a message here that contains an array, Angular and React. It can even do a join on an empty string. Yes, that will look nicer. Angular and React. This is what the manager is showing us. That is, we already have access to this variable. If we, for example, try to add something to this array using the add method, say in view.js, and then call managePrint again, we will get a new value. In other words, we are still interacting with this variable, but it now acts as a private variable for the manager object. In other words, this is implemented using closures because these two functions that we return have essentially closed over this value. It is not accessible from outside, but we can still interact with it. Okay, the next example is about closures, the classic example that is often asked in interviews. He is with set timeout. He will talk about synchronization a bit later, but for now, let's break down a simple example. Let's say I will create a Fibonacci array with the values 1, 2, 3, 5, 8, and let's add that 5 plus 8 equals 13. So we have a task. We have a for loop where on each iteration we create an index I which is set to 0 by default. Next, we will iterate over the length of the entire array, which is the Fibonacci array, its length property. And then we increment the index I, or what is our next additional task? We need to output all Fibonacci numbers to the console after a certain delay, meaning we can use setTimeout to pass a callback function that takes no parameters. Let's say we will output everything every 1.5 seconds. And in the console, I can write the following. Let's say fib. Right away, I will use literals here, which are backticks, allowing me to write certain templating using this syntax with a $sign and curly braces. So Fibonacci at index I. Similarly, here I write Fibonacci at index I with such a value. I will comment out this manager so that its unnecessary console logs don't interfere with me. Basically, what are we expecting? Well, indeed, after 1.5 seconds, we should get 0, 1, 2, 3, and so on everywhere, along with the value of this array. However, if I run the script, then after 1.5 seconds, I get this interesting picture that in reality we are currently accessing the 6th index. And each time we access the 6th index 6 times, and all of their values are undefined. And here a question may arise about what is actually happening, and you will need to explain how it works during the interview. In reality, we only create the variable I once, and then it changes as a reference, meaning there is only one variable I that exists here. The for loop executes quite quickly, so when the variable I equals 6, we then check if 6 is less than the Fibonacci length, which is 6, and 6 is not less than 6. So we have 66 less than 6. False, yes, and after that the for loop does not work. But I is already taking the value 6. Either way, there is no such index. A maximum index is 5, yes, and that's why we see the number 6 everywhere here. It's undefined because we are accessing the 6th index after 1.5 seconds, and everywhere it is undefined. How can we fix this? There are two ways. The simplest way is to change it to the variable LED because, as I said, the variable LED exists only within the block scope. In this case, the block braces are these curly brackets. So if we run the application now, we will see the result we need, meaning everything works. However, if we cannot use ES6 syntax, closures come to our aid in this regard. And next, we will consider the concept, but for now, we can already see it in action. That is, we can close these specific values in the following way. So we wrap everything in parentheses, and then we will immediately invoke these parentheses. Inside these parentheses, we create a function that will input certain values into asset timeout. And this function will take a parameter, for example, j. That is, I want to name it differently so that it does not overlap with this I. Now we will use the variable j everywhere. But where will this variable j come from? We will take it instantly from the current iteration I in this way. Now we will talk about this concept in more detail, but the point is that we are essentially closing these values, and if we look at the result, we again get valid data. Here are some practical applications of closures. This task is often asked in interviews, so keep it in mind. Since we touched on this topic, let's talk about the next one, which is abbreviated as f.js, a common term in programming. If we translate this abbreviation, it is written as immediately invoked function expression, which is a term used to describe a function that is executed right after it is defined. That is, it is a certain function expression that executes instantly without waiting for any other code to run. And this is exactly what we have been discussing in the context of JavaScript programming. Here, essentially, we can also consider a similar example, just as we did before. That is, before this, it was also an IIFE, immediately invoked function expression. The whole idea boils down to the fact that, essentially, we can create certain functions that will be invoked immediately. And they are often used to create some local scope, for example, as shown here. In other words, we have captured the value at a certain moment and created our specific scope in this way. Such IIFE, immediately invoked function expressions, are usually surrounded by parentheses, and essentially they are invoked immediately. That is all you really need to know about them. Here we can create, for example, an array of results. Then I want to do a for loop. Let's say var I equals 0 and less than, let's say 5, and for example, at ++. For instance, we can also add a slight pause. And on each iteration, I want to add to the array using the push method. To place a function, meaning that each element of this array will be a function that will return the variable I, and now, what can we look at? Let's write console.log I here instead of returned. It's basically the same thing. And now I can access the result, say, by index 1 or, for example, by index 2. And considering that this is a function, I can invoke it right away. If I look, I get a 5 here. If I, for example, access the 4th index, the last one, I still get 5. And this happens because we are using the var keyword here. And when we access this console.log, we are referring to the variable I, which in this case equals 5. How can we fix this value so that everything works again? Well, we can, for example, comment all of this out, and the result will remain. We can repeat a similar approach as we did before, meaning we have a for loop, and then we can create a copy of the variable I using the IIFE. So here I take an anonymous function and wrap it in parentheses, and this anonymous function will essentially be invoked immediately, right away. Here, I am kind of writing the parentheses already. Here, for example, I can create a variable j that equals I, meaning I can copy the current value of I into my own scope. And then I will push a function into the result that will do a console.load. But in this case, it will be j. And now, theoretically, everything should work. That is, if we refer to the result, say, at the second index, here the function, I call it, and we get 2. If at the fourth index, then we get 4 here. Because here, in our own scope, we copied the primitive values and are now working with our own value. In other words, it works like this now. Okay, the 8th topic that I want to discuss is a very important topic called context, and the file is accordingly named context.js. What is context? Often, context is confused with the concept of scope. If we recall what scope is, it essentially indicates the visibility of certain variables. When it comes to context, the context determines how the function was called. And he constantly refers to the keyword this in the current section of code we are working on. And related to the context are topics such as the call, apply, and bind functions. We will discuss them now. In the meantime, let's analyze the following example of how JavaScript works with context. So, let's say I have an object person, which has a field and a key called, for example, surname. Let's play a little game of Thrones. And by default, it will be the last name Stark. Stark, yes, I spelled it correctly. Now I want to implement the nose method, and it will be a function that takes 2 parameters. Let it have a parameter called what and a parameter called name. All this function will simply do is display to the console a literal with the following value, or I will write in Russian. I want to output a message that you know about, the variable what. And after that, I will output the parameter name. And here I will display the last name, and the last name will already relate to this object. That is, here I will no longer accept a parameter, but will refer to the context specifically to the keyword this. In this case, the keyword this will match the object person. Because this function created its own context, but it was already created in the context of the person object. Therefore, this is the same as person. As a result, this has a field called surname. And now what we can do is definitely gain access to the person object and absolutely call the nose method, which indeed means that our character will be aware of everything about this character. If I run this script now, we will get the message. You know everything Bran Stark. What is happening here? These 2 parameters are just regular parameters that we pass to the function, and they are simply outputted. This surname is taken specifically from this character, and by default, it is the Stark surname, which is generally understood. However, another character enters the system, who is not quite Snow, whom I will call, for example, John. This character, John Snow, has the surname Snow, so his surname will be Snow. Now I want to use the nose method of the person object to also output the key phrase for John. And for this, I can definitely use forced context passing. So, I want to call the nose method in the context of the John object. How can I do this? Let's say I can access the person object and call the nose method. Right now, I am not calling this method. Functions in JavaScript also have methods because functions are actually objects. And with this method, I can call the call method, which takes a new context as its first parameter. In JavaScript, the context is an object. That is, I can confidently pass John here, and the call method works as follows. He immediately calls this function with the required context, but he also takes the other parameters needed for this function, separated by commas. So what does John actually know? Knows absolutely nothing. And what is his name? Now, if we leave it like this, we will see that we called the knows method on the person object, but we are getting a different string because we called it with the context of John. And considering that in the second case we called this in the context of John, the keyword this refers to John, who has the last name Snow, so it is written as John's now. Similar to the call method, JavaScript also has the apply method. The only difference between it and the call method is that it has only two parameters. The second parameter is always an array. The arguments needed for this function to work. But right now, I will just wrap all of this in an array. And if I look, we get to know nothing Jon Snow. By the way, we can use ES6 syntax and also pass context in the method call and pass it as an array. But here we can already spread it using the spread operator. This way, we will still get the result we need. Similar to the call. In apply methods, there is also the bind method, which, like the call method, takes the context as its first parameter. It then accepts an unlimited number of arguments needed for the function. However, the only difference between the bind method and the other methods is that it does not invoke the function immediately. Instead, it returns a new function. That is, we can either call this function right away and get the desired result, or we can create a variable, say bound, and call this function separately. If we take a look, we see that we get the same result. The following example with context, that is in JavaScript, if we also talk about ES5 syntaxes, we could create classes using the keyword function. Let's say I will create a class person that will take two parameters, name and let's assume age. And considering that this function will be a class for us, we can use context here, meaning the keyword this, and for example, store name here. This .age equals age, meaning parameters that we pass to the constructor. And then let's say we can immediately look at the context of this in console.log. Now we can create objects from this class, that is, as an instance of this class using the keyword new. We will talk about new in the next module in a bit more detail about how it works, but for now, let's create Elena using the keyword new person, where we will pass the name Elena and let the age be 20. And I will comment out this whole thing so that it doesn't interfere with us. And even now, if I run it, I basically get the expected result, which is that we output the keyword this. And it is clear that this object, which is an instance of the person class, is labeled as person. Then we simply output its specific values. So if we create functions that are our classes, the context is available to us in this way. And this object, Lena, is equal to this. Object this. There are concepts such as binding, which refers to the bind method, for example, can be remembered that we explicitly pass some context. So there is explicit binding, which is called explicit in English, when we explicitly specify with which context we should call the function. That is, as an example, we can break down the following. Say I create a function called lockThis, and inside I will simply do console lockThis. Guess this is the keyword that indicates the context. Well, for example, I will just have some object that has a parameter, let's say, I don't know, equals 42. Let's make it better, well, equals 42. Furthermore, essentially, we can call this function in different ways by explicitly passing the context. That is, lockThis, for example, using the apply method with an object, using the call method, or using the bind method. However, in the case of bind, it returns a function, so we call it immediately. And if we take a look, we see that every time in this function log this, we get object 42. Let me also comment this out so it doesn't interfere. In other words, we explicitly pass the context, and basically that is the entire concept. On the other hand, there is implicit parameter passing, which does not involve passing context. In English, this is implicit. For this example, we can create an animal, for instance, that has a number of legs equal to 4 and also has an internal method called lockThis, which will be a function that logs lockThis to the console. So right now, if I currently call the lockThis method on the animal object, we will get the object in the context of which this method was called right now. In this case, we have an implicit binding of context because the context of the object in which this method was called is bound to this function. It's roughly like this. So I will comment everything. Here, let me add a comment here that this is explicit and this one is implicit. And lastly, probably what I want to demonstrate to you on the topic of context is how arrow functions indeed work. Because in fact, if we put it into words, when we create a function using the keyword function, this keyword essentially creates a new context for itself, and therefore for the object, we get the object itself. If, for example, we consider another example, let's say I create a function cat and the constructor of this function will take a color as an argument. Then initially in list color, I will place, for instance, a color and try to output the value of this in console. Log. We have already discussed how this works. However, I can also apply the concept of f here, and it is written like this. Inside here, I can define an arrow function that will be called. And this arrow function will log the value of, say, this in console. Log. And the parameter this here, by the way, is one of the few cases where a semicolon is needed. So just in case, I'll put one here. Next, if I create a variable cat, let's say with the color red, well, a red cat is a typical situation, so don't pay attention to that. In both cases, we get the context of this that refers specifically to the cat constructor. Yes, because this arrow function does not create its own context. And this is precisely one of its main advantages, aside from the directly convenient syntax. And considering that we started talking about classes, it's the perfect time to discuss how the keyword new works in general and what it actually is. So, I am creating a new file 09new.js. Essentially, this is basic theory in JavaScript, but it is important to understand how it works. And of course, you know, right, that we can, for example, create some class, let's say cat. In this case, the class cat will take color and, let's say, the name of the cat. So I will be assigning everything to the keyword this. And for example, I want to create just a variable cat. Through the keyword new, that is, when I apply it to a certain function, I get a new instance of that class, which will have these fields available. Color will it be, say, black in name. If we look at the cat in the console, we can see that we are essentially getting an instance of the cat class, and it has the fields that we pass to the constructor. In fact, it will be interesting to analyze how the keyword new actually works, because we can actually create our own keyword new. Yes, and it will work something like this. I will create a function called myNew, such as, for example, and in it we receive a constructor function. That is the function that is the constructor. Well, here I will use the REST operator to get an array of arguments, meaning all the fields we need to create a new instance. And essentially, what do I need to do here? As a result of the new operator, I need to return an object. So here I create an empty object. Next, using the global object class and its method set prototype of, I specify the prototype of the constructor function for this newly created object, meaning the constructor's prototype. We'll talk about prototypes a bit later. Essentially, I just need to return this object. That is, the constructor is a function, and functions have an apply method where I can pass the context with which we call this object and all the parameters in the array, which in our case is args. Just in case, I'll check that if this doesn't work, I simply return the object itself. Yes, and now it turns out that I can create a cat using the myNew function, where I pass the constructor as the first parameter. In this case, it's just the cat function, and then, of course, black and the name of a cat. Now, if we look at what a cat is, we get the same result. But this is what the native implementation in ES5 syntax of the keyword new looks like. In other words, this can be created, and it is clear that it is essentially just an interaction between objects. Well, here are a couple more examples regarding the keyword new and how instances of classes are created in JavaScript. That is, to be precise, not classes themselves, I apologize, but rather instances of classes. That is, we cannot create a variable cat in this way. We would get an error here. Or rather, we wouldn't get an error, but the variable cat would be assigned undefined because the function cat does not return anything. To make everything work, we use the new operator that we discussed earlier, and now we are getting the values we need. This was about the new operator, and ahead of us is a very interesting topic that I will call prototypes. Essentially, what can be said about prototypes? In fact, it is a relatively unclear construct in JavaScript because, at the very least, it is used in two different contexts. And it is very important to understand that, firstly, each object has its own prototype, which is derived from the parent element from which that object was created. To obtain this parent prototype, a special keyword is currently used. Two underscores, proto, two underscores, which essentially points to the prototype of the parent class or object from which this object was created. Well, it is certainly worth mentioning that in JavaScript, any inheritance occurs as prototype-based inheritance. Yes, when everything follows a chain, a tree, there is some kind of base class. From it, other classes are created, for example, and then, if we access a property of any object, it first looks at the property itself. If that property is not there, it looks at the prototype, which is an object. If it doesn't find it there, it looks at the prototype of that object's prototype, and so on. In other words, everything here follows a chain. So, with the help of the proto property, we can access the parent prototype. And, essentially, it is also worth mentioning that this became available relatively recently in ES6 syntax, because in ES5 syntax we also have the property object.getPrototype of. For this, I will comment on it, just so you keep it in mind. And there is a second context in which we talk about prototypes. This is the prototype property of various functions, which essentially serves to pass these properties to objects that are created. For example, using the keyword new. I think it will be easier to demonstrate all of this with an example. So, since we have gone through cats and dogs, let's not deviate from the chosen course, and I will create a class cat. This means that this time it will take name and color as the first parameters, and essentially we will pass the value of name to the keyword this and the value of color to color. So there is nothing unusual here, it is just a regular class. In ES5 syntax, this function essentially acts as a class for us. So, as I previously mentioned, with a function we can use the prototype property, which allows us to extend the functionality of this class. For example, I can add a function called voice, which will be a method, and everything I do in the console will output a value, say cat. For instance, I will output this name says meow, as it says meow. For instance, in general, I will have some kind of symbol like that, but I think the idea is clear that we are referring to the keyword this, which in this case, considering that the keyword function creates its own context for us, will refer to exactly this context, and it expresses its own voice. And now, essentially, we can create a variable cat using the keyword new and the class cat, where we pass the name of the cat as the first parameter and the color as the second parameter, let's say white. So now in the cat object, firstly, we have access to several fields, color, name, and more importantly, we have the method voice. That is, if we take a look, here's the line that we wanted to get. That is, by extending the prototype of the parent class for the instance of cat, we gain access to the voice method in this object. In other words, all of this works through the prototype. In this case, if we, for example, look at the cat prototype, what it actually is, I will run the script and we get here. In this case, an object that says voice function, but in reality, if you look, for instance, in Chrome, there will be even more properties. In this case, this field acts as a pointer to an object that has a constructor and corresponding fields that will be added for the objects that will be created from this class. It's roughly like this. Yes, now if we look at, say, an instance of the class cat, what it is, then, basically, I think it's clear that here we will only have the field's name and color, but as I have proven, we still have the method voice in the prototype of this object. And accordingly, considering that we are calling the method voice in the context of the object cat, it does not find it in the object itself, so it goes down to the prototype, and in the prototype there is the method voice, which is why it calls it. If we, for example, look at what cat proto is, we will see exactly the same object, which essentially is the prototype of the class cat. Moreover, we can compare them, and it should be true in theory because they are the same. What is also interesting is that we can take a look at the cat constructor in the console. There is a special object that points to, essentially, the constructor and parent class cat. And here we see that this is function cat. That is, this happens automatically when we use the keyword new. Now, the next topic that also relates to prototypes is the own properties of objects or the properties that are available to us in the prototype. Let's say I will create another function class, which I will call, for example, person. It will be completely empty, and I will refer to the personal prototype. It will set the property legs. Each person will have 2 legs, and the person, let's say, has a prototype where skin is, for example, white. The skin color is white, can specify black, and so on. Accordingly, I can create a person object through new person. Then, for example, I will set the name field for this person, which will be equal to the owner. That is, I am addressing the object itself, not the prototype. And now we can perform several checks that show us how the prototype chain works. So first we can ask if, for example, the property skin exists in the object person. Now I will comment all of this out again so that it doesn't interfere with me. I run it and get true, and indeed the IN operator checks whether such a property exists in the object or in its prototype. We can also look at person legs and see the value 2 here because this property is available in the prototype of this object. If we look at person, for example, there is no such variable, and we will get undefined because we haven't defined the color of the person's eyes anywhere. At this point, the field name is accessible to him, and we are obtaining ownership here. How can we determine which properties we have in the prototype and which properties are personal? For this reason, objects, which essentially have the object class as their parent class in JavaScript, have access to certain methods through this class, such as person-to-string. For example, we can call it, and we will get the string object. What is interesting is we can find using the hasOwnProperty method whether such a property exists on the object itself. Well, for example, polymay. I run this, we get true here. I will comment this out. However, if we ask whether the property skin exists on the person itself, we will get false because skin is actually located in the prototype. I can also talk about the topic of inheritance through prototypes. Let me write it down right away. About another way using the object.create method, which allows us to create certain objects using an already existing prototype. That is, let's say I will have some object called proto. This is my own name, so I can write whatever I want. Well, for example, here there will be a property year 2019. This is not so important just for the example. And then let's say I can create a variable my or just year. Here I will write my year to make it clear. Using the object.create function, where I pass the object that will serve as the prototype for this object as the first parameter. In our case, this is the proto. As the second parameter, I can pass various properties here that will be additional for the object. You can read the documentation. Right now, we are specifically dealing with prototypes. And now, interestingly, the variable myYear has the property year. That is, if we look at this in the console, we get 2019 here. We can also ask if the given object has the property year using the hasOwnProperty function. And we should get false here, because it is accessible from the prototype. We can also ask, for example, if myYear __proto__ equals proto, and we should get true, because this object is currently the prototype since we used the object.create function. However, there is one small detail that should be taken into account. For example, I commented out all the console logs, and now we are only entering the value of the year, which is 2019. Everything is fine, but now if I refer to proto, which is the prototype object, and let's say I change its year to 2015, something like that. Looking again at myYear, we can see that the value of the myYear object has changed because we modified it in the prototype. This is the first point. And the second point is the same. If we completely change the proto object, let's say to year, I don't know, 1999, and here I will write let just in case and run the script further. I still wanted to say that I changed the year, but it didn't change. It remained the same. Maybe if I change it to the keyword var, the result will change. myYear year. Well, all right. So I guess I overlooked something here. It turns out that if we change the value of the proto object to the same values, then for objects created through this prototype, the property does not change. Okay, it used to be a bit different. Perhaps the interpreter was fixed in this regard. That's roughly the story with prototypes. And the last topic we will cover is an important theme known as asynchronous behavior in JavaScript. Essentially, we don't need to consider too much information here, because in reality, JavaScript operates on a single thread. This means that there can be no talk of asynchronous behavior. As you know, JavaScript handles some truly asynchronous tasks quite well, such as various timeouts, server requests, and possibly some events that are present. How does all of this work? It all became possible thanks to the concept of the event loop in. How the call stack is implemented in JavaScript. So let's break down a very simple example. For instance, I will create a few functions, like arrow functions, that will simply log the message first to the console. Then I will have second and third. That is, there are 3 such functions, and I will output them as simply first, second, third. If I run this code, everything is clear because they are output sequentially, and there are no surprises. The surprises begin when we want to wrap the second function in setTimeout, for example, but we want to call this timeout after 0 milliseconds, meaning it is essentially synchronous. And now, if I run the script, we get a slightly different situation where first is entered, then third is entered, and only after that second is entered. You might ask how this works, because here we are passing a 0 millisecond timeout, and in theory this set timeout should execute immediately. Here, let's just quickly go over how this interacts, because when the interpreter reaches this line, it takes and pushes the function first onto the call stack. So, it executes by calling console.log, and then, when it finishes, the interpreter takes it and throws it out. It finds the line set timeout and sees that JavaScript itself does not understand how to work with various timeouts, so it uses external APIs. He sees that this is essentially a synchronous thing, and with the help of third-party APIs, he starts to execute this timeout. That is, it throws in that when the timeout is completed, the function second needs to be executed, and it throws it to an external IP. Then he removes everything from closed tag, and it is clean after that. He enters the third function, also adds it to cost tag, it executes, he removes it from cost tag, and now it's cost tag post. Moving on. At the time we were executing the third function, the external APIs saw that set timeout was instantaneous, and therefore marked this function as needed for execution and placed it in a concept called the event loop. Essentially, it can simply be thought of as a certain queue. I apologize, not the event loop. I believe it's called the event queue. Not even event queue, but callback queue, which translates to a queue of callbacks. And there the event loop is already in action, meaning it runs through this queue, and when the call stack becomes empty, it takes a function from the queue and pushes it onto the call stack, which is why it gets executed last. In more detail, I have covered the concept of how the event loop and called stack work on my channel, and you can find more detailed examples there. I will have a hint for you. And basically, I think that we will conclude here. Because we have covered the very basic concepts that exist in JavaScript, which can be somewhat confusing or not entirely clear. So, as you can see, there is basically nothing complicated here. You just need to take a thorough look at it, get a feel for it, and dig into it a little. And when you write just a few of these test files, as I just did with you, it will essentially become much clearer to you what is happening here, and you will be able to navigate through it. A little tip on how to handle interviews in case you can't, for example, explain theoretically in words what is happening here. I'm saying, okay, guys, it seems I've forgotten the theory a bit right now, so let me just show you an example of how I understood the question correctly, that is, how this concept is applied. And, accordingly, you will check if I understand correctly that this code relates to a certain concept. Then, using an example, you start to explain what is happening. For instance, in closures, write a structure like this. Well, you will say that this function, called IIFE, takes and closes over certain values, which is why we get the desired result. Or that the function in this case indeed has access to the upper scope. So take this advice, it really works, and it makes going through an interview much easier. And with that, I will say goodbye to you, because I have talked a lot today. I really hope that this material will be useful to you and that you will find something new and helpful here. If that's the case, you can share this material with other guys who are trying to understand the basics of JavaScript right now and, in general, figure out what's going on here. The description of this video also contains information on how you can support the release of similar content. I would be very grateful. You can also check out the courses I have in the description. For now, it's Angular and React. You can check them out at a very favorable price, and I would also be very happy to receive your feedback, which includes comments on YouTube, likes, and subscriptions. And I would be very grateful if you could hit the bell icon that allows promoting similar videos. Now I am definitely saying goodbye to you. You will find the source code in the description of this video, and we will see each other in other videos.